Alright, you guys, we're going to talk about inverse variation. So many days ago, we talked about direct variation. And all it was a nice little linear equation where it went through 0, 0, and it had a little constant k on the front. We're going to talk chapter 11, section 6, about inverse variation. And I remember this because it means one of my variables is going to be in the denominator. So our learning objective is to write and graph equations for inverse variations. And remember, when your learning objective is to graph, always expect graphing to be a part of your notes. So if you're out taking notes on your own, make sure if the learning objective says to graph, you have graph in there somewhere. And then to compare direct and inverse variations. All right, so let's define inverse variation. There is two ways to write the same thing. You can go x times y equals k. K is the number, x and y get to stay x and y. Or you can write it as y equals k over x. Go ahead and take your pen and circle this one. We will use it probably more like that as a y equals, because usually we graph in terms of y equals, so that is more, and that's how I usually recognize inverse variation. The constant of variation for an inverse variation is k, the product of x and y. So to find k, you just take your x value and your y value and multiply it together. Pretty easy. All right, so let's see how we write this as an equation. They're going to tell you if you have inverse variation, they're either going to give you data points, which you can use to find, to check, or they're just going to say straight up. It varies. No surprise. Suppose y varies inversely with x. They're going to tell you y equals 8 when x is equal to 3. What is the equation for an inverse variation? So what we're going to do is we're going to take x and y, x times y, and find out what our k value is. That's what happens here. X times y equals k. 3 times 8 equals k, so k is equal to 24. That's not the equation, that's just k. We're then going to take our equation, so if I were writing this, I'd write it like y equals 24 over x. We just replace the k with a number. That's already easy, right? Multiply two numbers, put it into an equation, done. Wash our hands. So let's do our got it and see if we got it. Suppose y varies inversely with x. They tell us that. So we're going to go y is equal to k over x. And all we're going to do is find k and put it in, and we're done. When y is 9 and x is 6, what is an equation for the inverse variation? So my k is x times y. 9 times 6 is 54. So my equation is y equals 54 over x. All right, so let's look at how we would use this. In physics, the weight needed to balance a lever varies inversely from the fulcrum to the weight. The fulcrum is where the point that you're balancing on. How far away from the fulcrum should the person sit to balance the lever? So this guy, he weighs 160 pounds. He is X distance away from the fulcrum. And our elefante, he is 1,000 pounds, and he is 7 feet from this fulcrum. So our 1,000-pound elephant is 7 feet away. Our 160-pound person is X feet away. The weight and distance vary inversely. So let's get our variables together. Weight 1 is 1,000. Distance 1 is 7. Weight 2 is 160. Distance 2 is x. So weight 1 times distance is equal to weight 2 times distance, because they're balancing. That would be 1,000 times 7, 160 times x. 7,000 equals 160. You divide both sides by 160 and you get x equals 43.75. The person should sit 43.75 feet from the fulcrum to balance the lever. That's a long board. 43 feet long. That's like 3 of these rooms. All right, so let's practice that. 120-pound weight is placed on a lever. Let's draw a picture. Here's our lever. He's like a little thin rectangle. So he's 120 pounds. I guess we should, oh, it's just a weight. So we'll put like a little oval. 120 pounds is on a lever 5 feet from the fulcrum. So let's put a little balancing point there. Let's mark this distance as 5. How far from the fulcrum should the 80-pound weight be placed to balance the lever? Do a little 80-pound weight here, and we are going to make this, make the 5 feet right here. We're going to use the same method that was up here. They did 120 times 5 equals 80 times x. We're just using the same pattern as they used above. 120 times 5, I think that is 600. Because 12 times 5 is 60, and then we put another 0. We're going to divide both sides by 80. 60 divided by 80 is, 8 goes into 67 times. And that's 56. And that would be 4/8. 7.5. Get my calculator out because sometimes math is crazy. So we got 600 divided by 80. Yes! Love it when mental math comes together. So 7.5 feet is our answer. Several graphs of inverse variations, x, y equals k, are shown at the right. Notice that each graph has 2 unconnected parts. So if you're this blue graph here, x, y equals 6, it has like a sideways U shape here and a sideways U shape here for in the 4th quadrant. If you're already negative, then it has the sideways U shape in the, I'm sorry, this is the 3rd quadrant. In the 4th quadrant and the sideways U shape in the 2nd quadrant. When k is greater than 0, the graph lies in the 1st and 3rd quartiles. That is up here top right, and that's down here bottom left. When k is less than 0, so when it's negative, the graph is in the 2nd and 4th quadrants. 2nd is the top left, and 4th is the bottom right. Since k is a non-zero constant, x times y cannot equal 0. Neither x nor y can equal 0. None left. Zombie apocalypse. What happens if y equals 0? No. As it moves away from the origin, the graph of an inverse variation equation approaches the x-axis and y-axis without actually intersecting them. So there is no X or Y axis. Very interesting. So we're going to graph some of these making a table, and then we're going to check our graph using Desmos because he is our awesome friend. Okay, so the problem says, what is the graph of y equals 8 over x? So when the question is asking for a graph, I expect a graph out. If you write a random number, when it says, what is the graph, you will not get points. And I'm only saying that because that is what happens. You guys here are smart enough to write a graph when it's asking for people that don't. All right, so make a table of values. So you make a little XY table. So y equals 8 over x. So when I have negative 8 for my x, 8 over negative 8 is negative 1. When I have negative 4 for my x, 8 divided by negative 4 is negative 2, etc., etc. When I plug in 0 for x, it is undefined because you can't have 0 in the denominator. Not allowed. Let me think. So if you look at the graph, you get a first quadrant and a third quadrant graph. So that makes sense with our k being greater than 0. And there's your graph. Easy. All right, so we're going to do the same thing. Let's extend this page. So what is the graph of negative 8 divided by x? So let's make a little table. So I'm going to use the same values they had up here. Negative 8, negative 4, negative 2, negative 1, 0, 2, 4, 8. So when I put negative 8 in for x, negative 8 divided by negative 8 is 1. Negative 8 divided by negative 4 is 2. Negative 8 divided by negative 2 is 4. Negative 8 divided by negative 1 is 8. Negative 8 divided by 0 is undefined. Can't divide by 0. Negative 8 divided by 1 is negative 8. Negative 8 divided by 2 is negative 4. Negative 8 divided by 4 is negative 2. And negative 8 divided by 8 is negative 1. All right, let's graph that. Let's pull out those points. So on my x-axis, I'm going to have to go, let's count by ones. We have to go from negative 8 to positive 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. 3, 4, 5, 6, 7, 8. And then y has to go from 8 to 8. So let me make mine longer. 1, 2, 3, 4, 5, 6, 7, 8. This is why I use graph paper, kids. All right. So when x is equal to negative 8, y is equal to 1. When x is equal to negative 4, y is equal to 2. When x is equal to negative 2, y is equal to 4. And negative 1 and 8. So it's this nice little sideways U. And because I know, I read what, and I said it out loud, I know that it's going to, the other side of this is going to be in the fourth quadrant. So when I'm 1, we are 8. When we're 2, we're negative 4. When we're 4, we are negative 2. And when we're 8, we're negative 1. So it's the other matching U shape. All right, that's graphing. Graph. And then let me show you how to use Desmos to check that your graph is worked correctly. So desmos.com/calculator, and you just type in y equals -8 divided by x. Does that match what we had here? Yeah, pretty close. And nice when technology does the work for you. Okay. So just so you can put an eyeball on direct variation versus inverse variation. Direct variation is a straight line that goes through the origin. Your slope could be positive or it can be negative. Inverse variation is these U-shaped graphs with, if it's positive, it's in the first and the third quadrant. If it's k is negative, it's in the third and second and fourth quadrant. All right, so we're going to have to do two things. We're going to have to determine if it's direct or inverse, and then identify direct or inverse. So we know that if it's inverse, we have x times y is equal to the k value each time. So we have to determine, and then direct variation is, so k is equal to y over x. So k is equal to y over x. So direct variation, our k value, we should get the same, when we divide the x and the y, we should get the same value each time. I'm going to test for inverse first, because I find multiplication a whole lot easier than division. So let's test this. If our inverse test doesn't work, then we will go to the division part. So we're going to go 4 times 12. Negative 12 is negative 48. 6 times negative 18. Now you're testing my skills. If it's inverse, it should be negative 48, not negative 48. So our test for inverse variation fail, because k should be constant. I don't know why k means constant, but it does. 8 times negative 24. Yeah, negative 192. So this is a big fail. So let's do the division. If the division works, then it is direct. So I'm going to say it's direct, but we are going to double check. So we take our y value and we divide it by our x value. I get negative 3. So let's test to see if the rest of these are negative 18 divided by 6. I don't need a calculator for that. That is negative 3. Negative 24 divided by 8. So this one is direct. Alright, so let's look at this over here. So we're going to test for inverse first. X times y, and if that doesn't work, we'll go direct. So what is 4 times negative 12? 6 times negative 8, and 8 times negative 6. Yay! So it's inverse. So we do the test, and we see which one makes sense for us. All right, now we got to identify it. Does each situation represent direct variation or inverse variation? Explain your reasoning. You buy sweaters in a clothing store for $35 each. I agree. It's direct. Because you're multiplying straight up to find, if I buy 12 sweaters, then I'm multiplying 35 by 12. So our K is 35 every time. Let's look at B. Hopefully this is inverse. You walk 5 miles each day. Your speed and time spent walking vary each day. Well, if you look at so distance equals rate times time. You know your distance is 5, and you don't know your rate and time. This looks an awful lot like our constant equals x times y. So we're going to say that that is inverse.